Hi, welcome to today's statistic lesson. This is Mrs. G from Gregory Middle School, excited to share with you all about measures of variation as they relate to dot plots and interquartile range. There's a lot of vocabulary, so at any time, go ahead and stop the video and take notes. As we look at measures of variation, there are measures that describe the distribution of a data set. You should already be familiar with range. We will be discovering what interquartile range looks like in this lesson, and you will be learning all about mean absolute deviation in the future. So let's start off with a quick review of range. When we determine range, we have to identify what is the largest and what is the smallest value in our data range, or data set. So I have arranged them from the smallest to the greatest. So in order to find the difference, we have to identify 37 as the largest, and then we would subtract 18, which is the smallest, which gives us a range of 19 data points between 18 and 37, which identifies 19 as our range for our data. We further look at measures of variation by identifying key pieces of vocabulary. As we are identifying quartiles, a quartile of a data set are found when we divide the data into 4 equal parts, hence the name quartiles. When we look at a full set of data, we can easily discover the second quartile, which we will abbreviate as Q2, by finding the median of the entire data set. When we divide it into 2 halves, we have an upper half and then we have a lower half, which will be our upper and lower quartiles. So what that looks like is, if here is our data set, we can see based upon this information that when we start to move our way to find the middle set in a number that is in order, we can see that we do not have one isolated number. So therefore, because we have an even set of data points, we have to find the average, and the average of 28 plus 30 divided by 2 gives us a median of 29, which represents our quartile 2, or our second quartile. As we are looking further at our measures of variation, we need to identify the first quartile and the third quartile as well. So once quartile 2 has been identified, we will use the lower half of the data and find its median, and this will identify our first quartile. We then would find the median of the upper half of the data, and this will identify my third quartile. So when we look at this information, we understand that this data set, the median of this data point would be 29. We repeat the same process for the lower half of the data, recognizing that because this is an odd data point, we easily can see that our Q1, or our first quartile, is represented by the value of 22. We repeat the same process with the upper portion of the data and ultimately end up with our Q3 is represented by the value of 32. Okay, we are going to use both the third and the first quartile to find the IQR. And the difference of the third quartile and the first quartile will give us our interquartile range. Our IQR represents the range of the middle half of the data and is another measure of variation. So we will use this data to recognize that when we find our Q1, that represents the value of 22, our Q3 is represented by 32, If we use the IQR formula, Q3 minus Q1 is represented by 32 minus 22. When we substitute those values in, we get an interquartile range of 10, which tells us that the data in the middle, 50% of our data represented between Q1 and Q3, has a range of 10 data points. We also recognize that we could find Q2, but that's not important when we're only looking at the interquartile range. So let's do a little bit of practicing on a problem from Big Ideas using a dot plot on lesson 9.4. So this dot plot recognizes and shows the top speeds of 12 sports cars. Find and interpret the interquartile range of the data. So when we look at a dot plot, keep in mind that these values down here represent the speeds of the car. Each dot represents a different car. So this car travels 220. There are two cars that travel 230 miles per hour. There's none that travel 235. There are two at 240, one at 245, and so on and so forth. So we are trying to determine the interquartile range. So to do that, we first need to organize our data and represent that each one of our cars or each one of our dots are organized in a manner from the smallest or the slowest speed up into the fastest speed of 270. We then will divide out the data in order to, as you cross them off, we come up with an even set of data in the middle. So 245 and 250 give us a mean or a median of 247.5, which is our median or our mean of these two data points. Once again, this is 6 data points, so you are going to have to find the average again of the middle set of the data. So 230 plus 240 divided by 2 gives you a quartile 1 of 235. And we will then repeat the same process for the upper portion of the data, and we will get the averaging again of the middle 2 data points, which gives us 255 as Q3. So keep in mind we are looking for the interquartile range using the formula of Q3, 255, minus Q1, 235, and therefore the interquartile range will be 20, which represents the fact that 50% of the cars, or the interquartile range, the inner quarter, the top or the inner part of the data, 50% of the inner portion of the data ranges only 20 miles per hour of a speed differential. So 50% of the cars only range in speed difference of 20 miles per hour. Hopefully you can use this information in this video to continue using dot plots to find quartile ranges. Have a great day.